My name is Albert Lewandowski. I am the Big Data DevOps engineer in Getting Data and also the CTO in Almine, where I'm focused on developing smart city and IoT solutions. And I also work as the editor. So mainly at present, I'm focused on doing ops stuff. So it's a short agenda, but it's not important. And the first thing on which I would like to start my presentation is about infrastructure as a code. So I think the whole presentation will be about topics that you know very well, I suppose, but I would like also to make a short summarize of the basics and how you can implement it in your infrastructure. So the first thing is about providing absolutely everything as the code, but it's not the most important in terms of the things about which we will talk later. And here you can find the short list of the available services in each the most important and the biggest public cloud providers. And the first thing on which I would like to be focused on is about documentation. And it's really important in doing technical stuff is about providing documentation. In many projects, I have met situations in which the only presentation about used services is in PowerPoint. And I know that most of us do not like writing documents, but it's really important that we need to make everything for not only developers, engineers, but also for operational team and also some business analysts that would like to understand what we are doing and how it works under the hood. I would say that adding something to the README is really useful and it doesn't take much time. So the next thing is about monitoring. So the monitoring is absolutely the most important thing in terms of real-time processing platform, because we need to have absolutely everything monitored and we need to understand what is happening. When we lose any events, it can cause some business loss. So we are not interested in doing any loss and we want to improve profits and to make our platform really stable. So I would like to be focused on the Prometheus because the Prometheus, the whole Prometheus ecosystem that I will describe later. And in Getting Data, we are mainly focused on building our monitoring system that uses Prometheus. So the first thing that is really important in terms of using Flink in the production environment is about using service discovery, because we need to know which job on which host and on which port exposes its metrics. And also you can find one ready service discovery script written in Python, but I would like to tell you that it doesn't work in the production because it does not provide information. I would say in real time, because the script that you may find in the internet, it only works if your jobs work all the time over some weeks, and it will refresh its lists only when it will be restarted. So it doesn't work. But if you will write really simple script that has some state, it can write the latest information in the file, then you can provide really great service discovery. And it's also important to check how many ports, in this case, should be watched or should be checked by our script. The second thing about Prometheus is about providing high availability. By default, the whole installation and configuration process of the Prometheus is really simple, and Prometheus does not require a lot of resources. But if we would like to provide high availability, then everything becomes much more complex. And in this case, we should to ask questions to ourselves or different teams. Do we need or have data? Because by default, the Prometheus time series database can contain data for up to 30 days. And Prometheus by default is not designed for storing all data. And it's also important to monitoring Prometheus itself because it can go down as any different process. And the first scenario in which we can provide a high availability for Prometheus is about adding 2 instances that scrapes the same metrics all the time. And surely you can also add the a proxy, that is the proxy that provides single point of access for different services like Grafana. But during the scrapping process, then you need to have two instances that do exactly the same all the time. Fortunately, the alert manager can support working in high availability setup. So it's the simplest option that you can provide to have high availability. The second option is much more complex, and here you can find the three, I would say, the most mature projects that provides high availability with cold storage, that you can store a lot of historical data. So the first thing is the Cortex, and it comes from the Grafana. The second is M3DB, and it's from Uber. It's part of the M3 project. And the last is Thanos. And at present, I suppose that Thanos is the most popular. But as you can see, the whole installation, configuration, and maintaining process is much more complex. So it's really important to choose the right solution for right project and to understand what kind of needs have to be met by our solution. And what about Spark jobs? In most cases, the Spark jobs are ephemeral, so they need to process some data and then they can finish. It's not like the Flink jobs that must run all the time, all day, all night. In terms of the Spark jobs, we should go with some different solutions. We had in two projects during the last months the target to take all the metrics from the Spark and to expose them to Prometheus. And from my experience, I would say that the best way to achieve it is using the stats desync that is built in Apache Spark package, then send these metrics to the stats exporter when we need to remap the whole configuration, and then we can expose it to the Prometheus. And it works. We don't have any issues with incorrect timestamps or that the metrics are still shown in Grafana even when the Spark job doesn't work at the moment. And it's also important, and the biggest difficulty in this process is about preparing the mapping from the statsd to me Prometheus format. So for example, during the last project, when we have prepared something similar, we have started from the remapping config that contains over 200 lines, but we finish with the quite small file that contains about 20 lines. So it's also important to test it and to improve all the time. And in terms of Flink monitoring, because it's crucial, and in most projects, when we talk about real-time streaming platform, it's really important to check what's happening under the hood, under the Flink, because it's also interesting that at present, most threads that you can read in the internet about Flink is in Chinese, because Chinese companies use this a lot, and even in the documentation, you can easily find every information about Flink in Chinese. But for example, you need to wait for the translation to English. So the first thing about I have talked well a moment ago is about discovering new jobs, how we can achieve it. And as I would say, it's the best way is to prepare the script that has the state, and we can check on which host and on which ports the metrics are exposed from the Flink jobs. And it's also important to check what's happening in the log files on the Flink jobs. And if we talk about monitoring the Flink, we also have to have the monitoring how many restarts happen, because Flink is great also due that it can provide its own restarts. But it's not great when the Flink jobs will restart simultaneously each 5 minutes. So we need to have the alert, because in this case, the action from the human operator may have to happen. So it's also important to remember that in terms that Flink is much more complex in comparison to the Spark in terms of the operational aspects, and especially when we talk about processing over 500, 600 thousands of events per second. It's also important to detect any issues in such processing. So about processing metrics, the first thing is about number of processed events. We need to check if there is any lag, any issue. And here I would like also to mention about monitoring the data sources. So for example, in some projects we use NiFi. So we would like to know if there is any issue, because then we can correlate some events and check, okay, Flink jobs are okay, and the problem is somewhere else. And it's also important to check its stability. And in terms of checking the log files, we need to check if there is any issue with making checkpoints, because the checkpoints saves the state of the Flink jobs. So it stores the information about process events that and it provides information for Flink that, okay, I've done this job and I need to take different events. And it's also important that still in the Hadoop ecosystem there are some bugs. And what about Kafka? Kafka is also critical components in many systems. And well, in terms of Kafka, we are in quite comfortable situation because there is the JMX exporter that works, I would say, perfectly, and it provides all needed information that you can easily expose to the Prometheus. So the most important metric about the Kafka is about the under-replicated partitions, especially when it grows really fast. For example, when the one broker would go down. And it's also important to check the ESR that shows the replication process, how it works, and if it works correctly. And it's also important to remember that there are still, unfortunately, some bugs. So, for example, when we talk about Flink, it's really tough that hardly ever there appeared one error related to this to the one bug in HDFS that is fixed in version 3.2.0. So it's also important to find such situations and also to prevent them, because the only method to overcome this issue was about restarting the Flink job with clear state. So clear state is the last thing that we should do in such platform, but it's also in some situations obligatory to overcome such challenges that are the bugs, and there is even the page in the Apache Jira. And also, it's also important to admit that we can run our Flink jobs on really different setups. The most basic is about installing the Flink package on the Edge node, from which we can submit the jobs to the Yarn cluster. The second option is about preparing the Docker container that we can install and from which we can submit the job to the Yarn cluster. So then we need to prepare also monitoring of the Docker container and the status of the Flink job. The third option is about preparing the Kubernetes cluster that will submit job to the Yarn cluster. And the last setup is about running everything on Kubernetes. And it works. It's really important in the Kubernetes world that something can run there quite stable. And the next thing is about monitoring and visualizing metrics, because scraping metrics is great, but what about visualizing and providing knowledge from them? All the available tools provide pretty similar interface. And I think it's great because all of them are really user-friendly. And here I have mentioned the most important things about the monitoring system responsible for visualizing metrics and providing dashboards. I think the most important thing is about describing absolutely everything, because from my experience, I know that sometimes people responsible for such platforms are not really technical, and they only know what they should do when they have the description, the documentation, the instruction. So it's also important to provide the metrics, the whole dashboards, even for people who are not interested in such technologies. And we can't forget about alerts. And the most important thing, and it's the quote from the Google Site Reliability Engineering book, is about alerts, that alerts signify that a human is to take action immediately. And I have seen a lot of different strategies for setting alerts. But frankly saying, alert means that someone really must take action. While in many cases, alerts are used too often. So after some time, users, even responsible for a platform, would not be interested in checking what kind of alerts, because when you received per day over 50 messages with alerts by Slack, Mattermost, or any different platform where there is a dedicated channel for such messages, then I would say you will not be interested in reading more. And even when you'll see the critical alert, then you will not take action. So it's really important to start from defining as less alerts as we can. So alerts are overused in many projects, and I would say it's one of the most common failures in many companies. And yeah, that's what I have told just a moment ago. And we can find a lot of solutions designed for setting up alerts. So as I am, I like YAML files and everything as the code. I would say that Alert Manager is the best solutions in many cases, but I see that most people would like to have everything as the alerts in Grafana, because you can quite easily set up alerts. Everyone will understand what's happening on the graph, especially when you will see the red line and the broken heart. So in many projects, even people decide to go only alerts in Grafana. And it's also great that at present, each solution provides plugins or webhooks for any different services. So you can really easily manage the whole monitoring system. And in terms of managing alerts, I expect that you know the PagerDuty, but the different tool designed for managing alerts is Alerta. So it's one of the most simple web Python application that you can imagine, and it is designed as the tool for getting all the alerts from different systems, like from the Alert Manager or from Grafana. And as you can see on the small screenshot, and you can even check the Alerta by checking it in the GitHub. There is also one link to the ready Alerta instance. And it's really a simple tool for managing alerts, but there are also a lack of many features that are required. So we made the small POC of the Alerta in one project, and not many people were satisfied how it works, because it's a really simple tool, but I would say mainly for displaying the alerts. In terms of operations team, I wouldn't say they were satisfied with it. The next thing is about log analytics, because they're reading logs directly from the virtual machines, from the bare metal servers, or from the terminal is not the most comfortable thing that you can do, especially now. So it's really important to provide all log files in one tool, and you can also check, debug your application, or you can see how the whole processing stuff went. And in one project, it was really important because we used such tool that I will describe in next slides. It was used not only by the developers, but also by the business team that would like to check if some IDs were processed, because it was crucial for them to process absolutely every data. And when they discover any lack of data, then they would like to check if there is something wrong with their Excel, or there is something wrong with the platform. So at present, there is one most popular tool, that is the whole Elastic Stack, and especially with the Kibana, that is a mature solution, and it provides really great user interface. But during the last 2 years, on the market there appeared new player, and I think it's one of the greatest tool at present, and it is a game changer from the Grafana labs. So it's the Loki that can take log files from the Promtail or Fluentd or FluentBit. And here you can find the short comparison between the Elastic Stack and Loki with Promtail. And it's really important to see the difference in terms of used resources. In our case, we have replaced 7 hosts that was used for the Elastic Stack. We replaced by only 1 host that was for Loki, and it was in the development environment. So, and I have also heard some stories when the 40 hosts for Elasticstack was replaced by the Loki, but in this scenario, it means also not indexing much content. So it really important to choose the right solution for the right business use case or engineering use case. Because Loki requires much less resources because it provides indexing only labels. And when you like to see anything in the log files, then it runs grep. And this grep is not as fast as indexing in the Elasticstack. So especially in terms of taking the business logs, when there will be a really great amount of business analytics from these logs, then you should stay with the Elasticstack. Surely it's not perfect. There is also some bugs, especially in FileBit in version 5 and 6. But still, it's the best solution. While for the developers, I would say that in each case, Loki will be more user-friendly. And it's also important that you can have all the dashboards in one tool, Grafana. So you do not have to relog into the Kibana, sign out from the Grafana. So it's pretty simple. And it's also important that the Loki is called as the Prometheus for logs. And one of the greatest thing about Loki that I really love is about making the dashboards based on the content of the logs. So in one project, in the one project, we had to detect one exact phrase that can appear in the log. And if this phrase will appear more than if I remember, it was more than 5 times per 1 minute, then we should trigger alerts. So we can, and it meant that the human operator need to take some action on the different part of the ecosystem that is not even related to the Hadoop. So it's one of the greatest thing about Loki that you can add the dashboard. And surely the overall performance of querying is not the best, frankly saying, but running such query, when we count the appearance of some words or some regex, then it works fine. It's also important to run queries on the data that is not older than 3 hours, because then the performance is okay. And when we run queries on more than 3 hours, then you can see that the Loki has some issues. And surely I have seen a huge improvement during the last versions, because we have started from using Loki in version 0.3 in the production, and it worked stable. But after upgrade to the newer version, especially that at present you can find the version 1.3, the overall performance it's much better, and you can also manage the whole performance easily from the configuration file. And it's also great when you have the Prometheus ecosystem already set up and people know how to use the PromQL. It's also great in terms of Loki that you can use the LogQL that is pretty similar to the PromQL. And as you can see, you can really easily run any queries and check what's happening. And it's also important to remember that you can relabel your log files on the host from which you take logs. And in case when you have a lot of logs and you really do not need to store absolutely everything, like basic information log, then you can make the filter directly on the machine. So then you will also reduce the number of the log files that you send. And as you can find in the Loki website, Loki is designed for working on the Kubernetes cluster, but surely it can work absolutely everywhere. And even it works for Windows instances. And in one project, we had to also take the log files from the two Windows servers. I think it's the Windows Server 2012 machines, and it works. Even it works with Windows 10. And I don't know why someone would like to scrap such metrics from the personal computer, but if someone is interested, then yeah, it works. And from our experience, the best thing there is that all metrics, all dashboards are added to the one tool. So you can also check and make the the whole content and some relations between the metrics, for example, from the Flink jobs, and to compare to make the comparison to the log files and what kind of content there are. And in our case, the whole process was about migrating from the Elastic Stack that does not provide all information in real time, where we have a lot of issues with providing all logs from from whole cluster, and also the lag when we run any queries was too big. So even in this comparison, the Loki is still quite fast. And it's a really stable solution because during the last 7 months, we didn't have any issues with the Loki and the whole installation process when we talk about the version of the standalone. So without the high availability, it's really simple. So especially when you will write the Ansible role for it. And I suppose that you can find even some pre-prepared in the GitHub. So then the whole installation and maintaining process is really simple. That's right. You need also to monitor the Loki process because, as you may found in the issues in the GitHub, there are some memory leaks, especially in version 0.4, as I remember. And surely you can also make the high availability setup for Loki. That is done by using the key value data store, and about also adding the object store like the S3 or Google Cloud storage. So in this case, the whole setup is a bit more complex, but it's still really simple. And it's also great that we can achieve high availability in pretty simple way. And you can also install the lock in the Kubernetes cluster. It makes sense, especially that it's the stateless application then when we have everything there. Because in default configuration, the Loki will store all indexes and all chunks in the local file system. So I wouldn't say it's the best setup, especially when everything is only on the one machine. And I would say the last part of my presentation is about implementing some site reliability engineering and DevOps methods to your data streaming platform. And here you can find absolutely the best definition about our platform and in which place we are. For example, when we talk about the Flink jobs, in one project, it was really critical for whole business that all jobs have to run all the time. So we have prepared the one job, but it wasn't written in Spark or Flink. But I'd say it's the small application that check if every job is running on the Yarn cluster. If no, then we run a dedicated Ansible playbook that restarts some Flink jobs if there is any need. So absolutely everything, every operational aspect of our work in these terms were automated. And frankly saying, when we have such tool, then the overall stability of the Flink is really great. And surely at present Flink became the really mature project. It's while in the older versions there were also some bugs. And what are the most difference about the site reliability engineering and DevOps? Because you can find a lot of articles about it, and I think still the best is taken from the Google website. That if you think of DevOps like an interface in a programming language, site reliability engineering implements DevOps, because the direct comparison of them is really tough, especially when we talk about different things. And the DevOps is a much more wider phrase that describes more things. While in terms of site reliability engineering, we are really focused on engineering things and delivering business value. And the most important thing about the implementing site reliability engineering methods, features, and all the buzzwords that you can imagine is about defining the SLI, SLA, and SLO, because we need to monitor if our platform can deliver the value that is required. So the best thing is about, for example, calculating if we can run the Hive query in shorter time than, for example, 10 minutes. If yes, then we can meet the requirements. And in terms of Hive, it's also really tough because, well, when we talk about the real-time processing and implementing any OLAP databases, then it's much better go through it or different tool than only staying with the Hive. Even with LLAP, that is quite difficult in implementing and making it stable when we don't have really huge cluster. The next thing is about CI/CD pipelines, and the continuous deployment seems to be perfect, but not in terms of big data applications, when any change should be deployed at correct time. And I think that automation is great, is needed, and it provides real value. It also provides us more free time for drinking coffee. But in terms of deploying an applications to the production, should be done by a human operator, by engineer or DevOps, to detect any issues, because we can test everything in the test, QA, or staging environment. But for example, in the production, there might be some issues related to the incorrect data in Kafka, or some differences in the configuration. So it's the basic. So it's really important to do absolutely everything as the code, and to not apply any change, especially to the staging or production, so the last two environments, manually, because you will forget about one small change that causes that the whole system works perfectly. So the dev environment is created for making experiments, but later you really have to run everything from the Ansible. Especially that you imagine that you disappear and someone comes to your job, and they don't understand absolutely anything from the IT, and they need to do some job. So it would be great if they would be able even to do anything by using your tools. And here you can find also the list that I expect you know very well. And I would like also to tell you about the Rundeck that we used as the user interface, mainly for running the Ansible playbooks, because in the beginning we have started from running some Ansible playbooks from terminal or from different tools, but we have finished with the Rundeck. Why? The first reason is about providing the web user interface. I'm not the biggest fan of it, but it's also great for example, for developers or from different people, that they can apply some changes only by applying one variable that is taken by the Ansible, and then the all magic happened under the hood and everything works as expected. The second thing is about having the audit. Who, when, and why run some job in Rundeck, because each thing in the Rundeck is called as the job. And you can really simple. And the third thing is about that you can really simply install the Rundeck on the Kubernetes cluster. You can make the and surely you can commit all changes made in the in the user interface to your repository. So it's really important that it's really friendly for administrators of this tool. And it's also great that you can make some pipelines directly. So, and that's the way we have applied our small application for checking if all Flink jobs work as expected. And the last thing on which I would like to be focused is about testing Ansibles. So you can use the molecule that is at present, I would say, the most mature project that provides it, and it's really useful to test it even before the merge request, because not everything can be tested locally or without running some things, and it can be easily added to your test in the Jenkins, to the GitLab CI, or any different tool that you can define your target environment, and then you can run if there is any issues related to the syntax, to the package, or to the configuration files. And it's also great that there is the Tox, and Tox is the tool that takes advantage of the virtual environment built in Python that is, I would say, really often forgotten even by the data scientists or by Python engineers. From my experience, and it's really great that it helps really in perform scenario tests. So when we talk about the molecule tests, the most important thing is the scenarios that you can prepare the exactly the same target environment, and you can simply validate if it works as expected and if there is no issues, because you can also write your tests, so the knowledge of the Python is required in this case. But I think even with some help of the Stack Overflow, you can achieve really great tool for testing Ansibles. Actually, on the beginning, writing tests for your Ansible can be a bit strange, but after some time, you will really like it. That you can check absolutely everything earlier, and when you run, well, everything works as expected. So it's really important that there are available such tools that enables such work. And well, I think that's all for today's presentation, because it was about a lot of different aspects of monitoring and alerting. So, well, I think it's the best time for questions and answer session, especially that I do not like having the presentation longer than 30 minutes, because I think more than 30 minutes is great time, but for doing some workshops or doing some exercises in practice, because the practice is the best source of knowledge, especially when we talk about the really fast ecosystems in terms of data processing, machine learning, and any different. So, well, thank you for your attention, and I am available, and you can find me quite easily in the internet, in the Twitter, LinkedIn, or absolutely anywhere. Thank you.